Hi everyone, welcome to Codeiento. Today we are diving into another super powerful coding pattern, binary search. Binary search is a like cheat code for sorted data. Instead of going to route each element one by one, you cut the problem in half every time, leading to a massive performance boost. Let's see how and when to use it. Binary search works by repeatedly dividing a sorted array in half. Start with left and right pointer at the array boundaries. Find the middle element. Depending on the comparison, narrow down the search space to either the left or right half. Repeat until you find the target or exhaust the search space. For example, imagine a phone book where names are sorted alphabetically. Instead of scanning every page, you open the book to the middle and decide where to look in the right or left half. This is exactly how binary search narrows down the location of the target, reduces time complexity from O(n) to O log n. Works well when data is sorted or can be transformed to behave as sorted. Let's check LetCode examples together. A super classic problem for binary search. Find the target in a sorted array and return its index. Initialize pointers. Left pointer start at index 0. Right pointer start at index 5. Middle calculation is left plus right minus left divided by 2 and it's equal to. Compare targeted with numbers middle. Target is greater than 3. Move left pointer to middle plus 1. New left pointer is equal 3. Recalculate the middle. Middle is equal 4. Numbers middle is equal 9. Compare it with target. Match found, return 4. Let's check the code together. Start with initialize left and right pointers. Loop until left less than and equal right. Calculate middle. Compare numbers middle with target. If equal, return middle. If numbers middle less than target, move left to middle plus 1. If numbers middle greater than target, move right to middle minus 1. Return minus 1 if not found. Let's check another example together. Find the first and last occurrence of target in a sorted array. We have an array and target is equal 8. Find the first occurrence. Left pointer is equal 0, right pointer is equal 5. Middle calculation is equal 2. Check middle numbers is equal 7. 7 is less than target. Target is greater than 7. So, move left pointer to middle plus 1. New left pointer is equal 3. Recalculate middle and it's equal 4. Number middle is equal 8. Match found. Update result to 4. To check earlier occurrence, move right pointer to middle minus 1. New right pointer is equal 3. Recalculate the middle. Middle is equal 3. And check middle. Number 3 is equal 8. Match found. Update result to 3. Final first position is equal 3. Final right occurrence. Repeat similar binary search, but move right pointer to middle plus 1 when target is found. Let's check the code together. To find the integer first, we will create a helper method, find bound, and we send the numbers target and boolean is first to our helper method. Define left pointer and the right pointer. While left less than and equal right, calculate the middle. If numbers middle is equal target, result is equal middle. For the first result, if condition will be right and right is equal middle minus 1. And depends on the other conditions, numbers middle less than target, left is equal middle plus 1. On the other hand, numbers greater than target, right is equal middle minus 1. And we will call our helper method for the last integer and we will send is first false. Return first and last results. Efficiently reduce the problem size by half in each iteration. Adapts to different problem variation to find first, last, or peak elements. Time complexity of O log n, much faster than linear search. Don't forget to like and subscribe. Thank you for watching, friends. See you in the next one.